So today we will see how to trace a recursion function. Usually it's easy to trace loops, but when it comes to recursion it can get confusing to trace the code. And in this video we will take an example of merge sort. To understand this video you should be knowing the merge sort algorithm, at least theoretically. Now let us start. Here we have an input array of length 4, and for the first time the merge sort is called in line number 34. Remember a concept that you will have a stack in the memory. Every time any function is called, you will track that function call in the memory, and every time that particular function returns, and so the track will be popped out from the stack in memory. Now for the first time when we call merge sort, we are calling a function and we will track it in our stack. So what is our input? Right now our input is 8 4 3 2, and the function that we are calling is merge sort. So here we have two functions, one is merge and one is merge sort. So here we entered line number 5. Since our length is not less than or equal to 1, we calculate the mid, we calculate the left and right. So in this case the left becomes 8 and 4, right becomes 3 and 2. So we come to the line number 13. So here we are calling a function. This is the first recursive call. So merge sort of left. So we are calling a function and we will track it. So merge sort of 8 4, and this is the function merge sort. Since we called merge sort, we will not go to the line number 14 now. We will directly jump back to the first line of this function. So the length of this is 2. We will not go to the less than or equal to 1 case. We calculate the mid again, and we calculate the left and right. So here left will become 8 and right will become 4. So again we come to the line number 13. Again we are calling merge sort for left. So left is 8 and we call 8 for merge sort. So now the length here is 1. So we hit the base case and return the array, which means since we returned, we will pop that. We no longer need that in our stack, and our left value becomes directly 8, or the array of 8. So now this is the first time we get to go to the line number 14 to calculate the right. Now the right value is 4 and we calculate the merge sort for right. Length is 1 and it hits the base case. We track it since we are calling it 4, and merge sort, since length is 1, it will directly return the array, and our right will become 4 here in line number 14. Since we returned, we will pop it out of the stack. Now we get to go to the line number 16, where we are returning the merge of left and right. The left is 8 and the right is 4. So since you are calling a function, we will write it here 8 comma 4, and this time it's not merge sort, it is merge. Since we returned from this function, we will pop it out, and now merge of 8 comma 4, we will get an array which is sorted array 4 comma 8. Since I already mentioned, you should be knowing how merge sort works. So we got 4 comma 8, which means we returned from merge. Since we returned, we will pop this entry also. Now we are done with left. Remember, we are done with left and we got 4 comma 8 as our answer. Now this is the first time we go to the right side of the actual input array. So for the left, we'll store it. We got 4 comma 8 as our input, and for the first time when we called the main input array, this 8432, we were stuck in this line 13. Now we get to go to the line number 14 for the right, and by passing the right, what is right? Our right is 3 comma 2. So we call merge sort for 3 comma 2. So here it is merge sort, and since the length is greater than 1, we get to calculate the mid, left and right. So here left becomes 3 and right becomes 2. So now we come to this left. After calculating left and right, we come to this left, we got the left and right. We come to this left and call the merge sort for left. We're calling the merge sort for 3. So we will enter it 3 and merge sort. And since it is length equals 1, it will be returned the actual same array. So left becomes 3. And now we get to go to the line number 14. So right, since we returned, don't forget to pop it out. Now since we are calling it for right, which is 2 and the length is 1, we call the merge sort for 2, which is merge sort. Since the length is 1, we get to go to the base function and we return 2. So again right becomes actually 2. Since we returned, we will pop this one. Now we get to go to the line number 16, which is the merge of 3 2. We will track it 3 2. This time it will be merge, not merge sort, and the merge will return here. Merge will return 2 and 3, which is an array. Since we returned merge, we will pop it. Now since we returned line number 16 for the value 3 comma 2, we will pop this also. Now what is left? The main array is left here. So we got the left, which is 2 comma 3. We got the right, which is 2 comma 3, and we got the left, which is 4 comma 8. Now we actually call the merge for all of those. So from left we got 4 comma 8, which is the output from the merge function, and from the right we got 2 3, which is an array. Now we will go to the merge and pass 4 8 comma 2 3. So these two arrays will pass to merge, and the output of the merge, and don't forget to track it. So here 2 arrays 4 8 and 2 3 will be passed to merge, and the merge will return an array which is sorted through 3 4 8. Since it returned, we will pop it. And now finally, since we returned from here merge, we will pop this one also, and we don't have anything on our stack right now, and we have our answer ready. And that is how you track a recursion function.